Hey there, friends. My name's Matthew. I'm the C# artisan, and this is the fourth video in my series on threads. And today I want to talk about thread safety. Now, thread safety is a term that can be a little bit intimidating. If someone looks at your code and is like, I don't know if that's thread safe, that might cause you a lot of anxiety. Well, I'm here to tell you that for the most part, thread safety is very easy to understand and actually pretty simple to implement as well. And to make my point, I want to use kind of a fun metaphor. So imagine that you and a friend are heading down to the swimming pool to go for a swim. You're going to just play around, have some fun at the pool. Now imagine that this pool has a diving board and you two are like, hey, what fun. Let's go do some dives. Now, I'm sure everyone will agree that it's very important to take turns on the diving board. If you both attempt to dive at the very same time, well, nothing good is going to happen. So in this metaphor, you and your friend are the threads, and the diving board is the shared resource, the shared data that you need to take turns with. So when we talk about thread safety, most of what we're talking about is just making sure that threads that need a shared resource take turns. Now, there are two basic approaches to this. One goes something like this. You and your friend turn to each other and you just have a little conversation and you say, I think we should take turns. And once you've agreed upon that, then everything's fine. You take turns, no one gets hurt. The other approach is to rely on the lifeguard. So the lifeguard is up there in their chair, they've got a whistle, and if one of you is on the diving board and the other tries to climb up and dive at the same time, the lifeguard is going to blow their whistle and say, hey you, stop! Only one at a time on the diving board. And that'll force you to take turns. So both approaches work. They both are completely legitimate, they work well. So let's dive into the code now and try to implement them both. Here we are back in our test code project, and I want to just take a second and review the code from last time. So we have this function, run thread with data, that creates a thread using the parameterized thread start. It initiates our thread data class and then starts the thread passing in the data. The thread then acknowledges the data that it got, it modifies the data and ends, and then the main thread logs out the changed values. So let's run this so you can see it in action. And there we see the initial values of 42 in blue, and then the modified values of 99 in green. So the question I asked at the end of the last video is this thread safe? And the answer is actually, as written, this is thread safe code. So this is an example of the two swimmers simply agreeing to take turns on the diving board. This is sometimes called the thread confinement or thread ownership pattern. And it basically means the data is shared, but it is only owned by one thread at a time, or it's confined to one thread at a time because of the way the code is written. So let's take a look at that. So here we see our main thread creating the data. So right now, data is owned by the main thread. And here there's a transition. The main thread starts the worker thread passing in data, and it has given up ownership of the data, not through any kind of explicit locking mechanism. There's no lifeguard here, but the way the code is written, there's a transition. Now we are inside of the thread proc, and now the worker thread owns the data. It's confined to the worker thread. It does its work, it can read and write the data, and then when it exits, control of the data transitions back to the main thread, which can safely log out these values. So this kind of cooperative pattern or thread ownership pattern works really well. This is completely thread safe as written, and it's also very efficient because we haven't had to essentially implement a lifeguard. So I want to now change this code. I want to break this and make it not thread safe so that we can now implement the lifeguard pattern, the locking pattern, to make our code thread safe. So the first thing I want to do is I'm going to make some changes here to thread proc. So I'm just going to take this out and let's implement this with a loop. So for int I equals 0, I less than 5 loops should be enough. And inside this loop, we'll put in a little delay of 1,000 milliseconds, 1 second, and we will increment data some number. So this is now going to loop 5 times. Every time it's going to increment some number. And here in our main thread, instead of doing thread.join, we're going to say while t.isAlive. So as long as the thread is running, I'm going to put in a smaller delay. We'll say 1/4 second. And then I'm going to read some number. So we can do fancy-logger.log. The current value of the number is, and we can use string interpolation, data.someNumber. And just for clarity, I'm going to also put in a log message here, fancy-logger.log, about to increment the number. So our worker thread is going to be looping, and every second it's going to increment the number. Our main thread is also looping on a different kind of polling cycle, and it's going to be reading that same value. So now both threads are really trying to get on the diving board at the same time. There's nothing in our code that would guarantee that we won't have a collision. So this is now not safe. So what do we do to fix this problem? So to fix this problem, we have to go back to thread data itself and make it thread safe. And we're going to do this with the concept of a lock. So I will implement it like this. Private object lock object equals new. And now in our getters and our setters, we need to lock before we touch the private data. So we'll say lock object, and then we'll access the value. And we'll do it again for the setter. And we'll do it again for this getter. And we'll do it again for this setter. So one question you might have is, does it matter what kind of object I use? No, you can just use plain old object for your lock. Another question you might have is, can I share one lock object across multiple properties like this? And the answer is yes, you can. This is safe. What this means is if one thread, let's say, is trying to access some number and read it, the other thread will be blocked from accessing some number for read or write, and also the other thread will be blocked from accessing some string. So this treats the lock kind of at the class level. Everything is locked to the same lock object. Now, if you want a little more granularity, and if you want one thread to be able to, say, read the number while another thread writes the string, then you would need multiple lock objects, one per property. They both work. It's a subtle difference. For this demo, perfectly fine to treat this as a kind of a unified data structure and use a single lock. So now our thread is thread safe. This is going to guarantee that we don't have a collision. So let's go ahead and run it and watch this thing in action. I will press enter to start. You should get 5 loops and then it'll be done. Perfect. So let's read it through. At first, we enter the main thread. We're going to run this procedure. And the main thread kicks off the worker thread. And you can see the worker thread is saying, okay, I'm starting, and here's my initial data, 42 blue. Meanwhile, the main thread is polling, and the worker thread is still alive. And so it's reading that the number is currently 42, 42, 42. Now, a second has elapsed, and our worker thread says, okay, time to increment the number, and it increments it. And then our main thread, which is polling, sees the change, 43, 43, 43, 43, and 44, 45, and 46, and then everything exits. So now we've implemented the Lifeguard pattern. We've put in some locks, and we've made our code explicitly thread safe. So there you have it. 2 basic approaches to making sure that no one gets killed on the diving board. I mean, that your code is thread safe. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.